Hello everyone. In the water industry, the demand for clean potable water has been on an increase with the population and economic growth development within the state of Sabah, Malaysia. Over the years, it has reached to the point where clean water supply can barely meet the population and industrial demands. There are a number of factors that can cause disruption of clean water supply. River pollution, maintenance of treatment plants, breakdown in the distribution pipeline, as well as water theft all contributed to it. And today, we are going to present our case study on the analysis on the delay in maintenance repair work completion for process critical equipment, PCE, causing disruption in water production by Jetama Water Sendirian Berhad. Before that, we would like to thank our Professor Madya, Dr. Siti Halijah binti Sharif, for her knowledge sharing and guidance on operation management and to the completion of this case study. This presentation has 7 parts. The first one is, of course, our team introduction. Second part is we will be looking at purpose and objectives, why we do this, and what we are going to do. The third part is on company profile, a brief description of Jetama Water Sendirian Berhad. The fourth part is on problem identification, whereby issues related to the operation strategies with regards to water production. The fifth part, we will be looking at findings and discussions, where discussion on the findings in line with operation strategy practices will be discussed. And then the sixth part is on recommendation. We will recommend possible solutions to the problems. And last but not least, our conclusion on what we conclude on this case study. Let me introduce to you my team members. Of course, our team member consists of me, myself, Welzan Simon, our gorgeous and energetic Miss Debbie Annabelle, and our dazzling and highly motivated Mr. Callum Mogindol. The purpose of this case study is to conduct fieldwork analysis on Jetama Water Sendirian Berhad with regards to issues related to operations management. And the second purpose is, of course, to propose possible solution and recommendations to issues identified. And among the objectives of this case study, the first one is to identify any issues or problems related to any one of the operations strategies with regards to the production. The second objective, to identify potential failure points or shortcomings of the current implementation. The third objective is to analyze factors that cause the problems by using any of the strategic management tools or techniques. The fourth objective, to discuss the findings in line with theories and practices related to the operation strategies. And last but not least, the fifth objective is to make a recommendation and elaborate possible solution to these issues or problems. Now let's look into the company profile, which is Jetama Water Sendirian Berhad. Jetama Water Sendirian Berhad is a subsidiary wholly owned by Sabah Development Bank Berhad (SDB), formerly known as Corporate Dynamics Sendirian Berhad. And to that, they have a total of 6 water treatment plants, which is located at Kasigui, Papar, Telibong, Tamparuli, and Tuaran, with a total production of 327,000 cubic meters per day. Jetama Waters is certified under the international standard ISO 9001-2015, and the laboratory is accredited under ISO 17025-2017. And then they use an advanced and a modern equipment, whereby this consists of telemetry, automation and SCADA, supervisory control and data acquisition systems. And up till this day, Jitama has 8 main departments, which consist of plant operation, maintenance, technical services, laboratory, quality and environment, safety, health and security, human resources, finance, and administration. Why we want to investigate this problem? Findings of the problems causing frequent disruption in water production in March to October 2021. Then how do we do it? We conduct an interview sessions with 5 main personnel that consists of plant operation manager, maintenance manager, finance manager, procurement engineer, and senior technician. And what is the problem identified? The problem identified is disruption of production due to delay in maintenance repair work for process critical equipment. And then this is very much related to strategic operation management decision number 10, which is maintenance and reliability. Maintenance refers to the activities involved in maintaining capability of the system, while reliability is the probability that a machine, part or product will function properly for a specified time under stated conditions. Now, for findings and discussions, I'll invite my friends Miss Debbie to continue. Over to you, Debbie. Thank you.
Thank you, Elzan. So before I continue to the group findings and discussion, I would like to clarify on the meaning of process critical equipment, or PCE in short. So basically, a few examples of process critical equipment are raw water pumps, we have dosing pumps, quality monitoring equipment, as well as totalizer and flow meter, and also filter system accessories. This is to name a few. So basically, all these type of equipment is very important, very critical in maintaining the water treatment production. Now I will continue to present our group findings and discussion on our analysis. So basically, our group first step is to do an interview session with 5 key personnel of Jitama Water, and these key personnel were already explained by Welzan earlier. The interview is done for problem identification, where each of the personnel interviewed were asked on the problem that occurred within March to October 2021, where the number of water production disruption reported more frequently compared to the rest of the months. After the problem was identified, causes contributing to the problem were identified further using Ishikawa diagram. And based on the compiled causes derived from Ishikawa diagram, a Pareto chart is then established to identify the vital causes for our group to tackle. This Pareto chart is basically established using the frequency of the causes to happen, contributing to the delay of maintenance repair work completion for process critical equipment. So as you can see here, Ishikawa diagram is the tool used to find the factors causing the delay in maintenance repair work for process critical equipment. Meanwhile, Pareto chart is the tool used to find the vital few factors that are going to be focused for improvement. So first, we will go to look at our Ishikawa fishbone diagram. We have here 4 contributing factors. That is man, and then we have machine, we have method, and material. So all these 4 factors will be contributing the delay of maintenance repair work completion for process critical equipment. So we have first in man, insufficient manpower. We also have staff incompetency. And then as for method, we have the delay in the whole procurement process. So basically, procurement process will entails the moment the procurement section have gotten the purchase requisition sheet or PRS until the item reach maintenance department for repair. And we also have here our method, the delay in maintenance troubleshooting. So basically the times taken by maintenance department to do the troubleshooting after there is report of equipment failure. Okay, and afterwards until the process of generating report and requesting spare parts for the repair. We also have interdepartment communication breakdown. So basically the communication between the production, maintenance, and also the procurement or finance department. And then for machine, we have unplanned breakdown. So unplanned breakdown means equipment breakdown that is not budgeted. So basically there is problem to get the fund to do the repair, and also insufficient maintenance tools to do the repairing work. So for material, we have unavailability of spare parts to do the repair, and also insufficient spare parts. And then last but not least, the late delivery of required spare parts when needed. Okay, so from the Ishikawa fishbone diagram, we compile it to a Pareto chart. So this Pareto chart is based on the number of frequency for each of these factors contributing to the delay. So we have here the number of frequency, the cumulative percentage, and the causes. Pareto chart is actually used to see the vital few factors. So as you can see, the arrow showing 80% cumulative percentage, and going down to the factors contributing to the 80% of the problem. So we have the 20% causes contributing to the total number of frequency causing the delay. We have trivial many. So these were all the trivial factors. And then we have the vital few, or the 80% cumulative percentage contributing to the frequency of delay. So there are three main causes. So we will focus on the vital few contributing 80% factors. So based on this Pareto chart, we can identify three vital causes or contributing factors causing the delay in maintenance repair work. The first one is the delay in procurement process, and then you have number 2, unavailability of spare parts, and then number 3, the delay in maintenance troubleshooting. So basically all our subsequent analysis will be based on these three contributing factors, or this vital few contributing 80% of the total number of frequency. And for the recommendation, I will leave it to Callum to present our recommendation, and the recommendation will be tackling only these three vital few factors. So over to you, Callum. Thank you.
This brings us to the discussion and recommendation. Based on the tools used, we can conclude that the main contributors are the inefficient time management of the system and procedures of the procurement and maintenance departments, starting from the customer request after the equipment breakdown until the completion of the repair. This is a current time function map of the maintenance repair of PCE. For a start, let's start with the plant operation. The plant operation is the client. They raise the WOR, and from there on it goes on to the CMS supervisors through email. The CMS supervisor would then manually enter the WOR into the maintenance software system before being forwarded to the maintenance team. The maintenance team will then take the initiative to troubleshoot the equipment before generating a maintenance report. The maintenance team would then raise a PRS for approval. The approval is a multi-layered approval, which would first go on to the maintenance manager for recommendation before proceeding to the HOD. The head of department would then approve the PRS and then submits the PRS to the procurement department. From then on, the procurement department will start the procurement process. The procurement process on average has taken 60 days before all the quotation and tender exercise has been concluded. From then on, the procurement would then issue a PO for approval. The PO approval has on average taken 13 days, and from there on, the PO would then be issued to the supplier or contractor that has been awarded the works. From the PO issuance, it has on average taken 90 days before the spares or the parts or goods has been delivered. And from then on, another 14 days for the maintenance team to proceed with repairing the plant critical equipment before handing it over to the plant operations. Now, throughout the entire process, there are multiple delays that can be seen. First of all, the manual WOR itself is already taking 2 days delay. Troubleshooting has also already taken 13 days. It can be seen that the approval process for the PRS as well as the PO itself is taking a total of 20 days, and whereby the main contributor of the timeline is the procurement process itself, which in total takes 60 days. This is the proposed time function map of the maintenance repair of PCE. Firstly, we look at the requirement for the CMMS supervisor to manually generate WOR into the CMMS system by providing software interlink between EWOR and CMMS. This would save us 2 days in total. Secondly, by setting up internal timeline targets for both the maintenance and the procurement departments, we look at the reduction of 37 days in total. And thirdly, we look at investing in a new online PRS and PO system for the procurement process. E-approvals alone for both the PRS and PO is estimated to cut the timeline by 30 days. In all, based on the previous 202 days, we are looking at a reduction of 52 days in total with the new proposed timeline function map. Recommendation for the unavailability of spare parts. The unavailability of spare parts is being contributed by the failure to do risk analysis on equipment to ensure that the spare parts needed for PC repair is readily available. Secondly, the procurement process itself for spare parts is taking too long. For the recommendation to improve, risk analysis needs to be done periodically by the maintenance department. And secondly, the procurement process itself needs to be shortened as proposed in the previous time function map. For the conclusion, utilizing operation management tools enables us to systematically lay out the causes for delays, categorize and focus on the main contributories, as well as investigate and propose in a time function manner. With these improvements can be made to solve, remove, and make efficient of the existing systems and procedures. This brings us to the end of our presentation today. Thank you and have a good day.